Building Digital Twin International Congress 2022. Presentation for Privacy Workshop. Privacy Metric Tool. Advanced Home Control Systems developed at Sphere with Software in the Loop. Advanced Control (SIL) is using AI to improve validation, increase sensor robustness and to include occupancy and media interaction. This needs a privacy concept by design, originally designed to comply with privacy limitations. The European Parliament on 5 April 2022, and the Special Committee on Artificial Intelligence in a Digital Age (IDA) published a resolution about on artificial intelligence in a digital age. BDTA Privacy Workgroup will propose a privacy metric tool to help in the design of these systems in construction. These are basic documents which may be used to prepare the workshop on the 26th. Some of them are summarized at the BDTA Doc 6 and the Privacy Metric Tool in Excel is presented at Document 7, File in Excel and Word Help File. Objectives of the workshop on the 26th are basically to prepare the draft for first standard, in case that partners agreed on the general methodology. Further discussions may define more aspects about categories, items and scores. But an agreement about the general approach would be a great step ahead.
Mathematical simulation is used in advanced real-time control in complex problems of environmental control and life support systems. In Sphere project, a residential building is considered with all its functional aspects: passive building, ventilation, heating and cooling, external meteorology, and humans. The same model may be used for design, commissioning and exploitation of the building. The model can be compiled in a deck with a simple user interface of inputs and outputs in real time, sampling of 10 to 15 minutes. The building has a limited number of physical senses which are interacting with the simulation deck model. Calculations are made on the fly step by step every 10 or 15 minutes, providing analysis of the house in real time. We can extract secondary magnitudes, residuals to detect deviations, implement predictive control or just other values not sampled. Simulation model can be located in small electronics at home, with no need of communication to the cloud. But it may be hosted in a server using web services as well. Some controls can involve human ventilation demand. This can be done with wearables interacting with sensors in the building. This information may be very sensitive and hence a privacy development need to be implemented.
A view of the systems involved may give an idea of the complexity of privacy content estimation. We will have sensors in several rooms of the house. This number is typically around 10. Sensors may be connected with Zigbee protocol and may have their own calculations in the edge instrument. They could be directly connected to Internet IoT. We will have equipment such as a home ventilation machine which have their own sensors and connectivity. Media service may be supplied by a service through Internet. We will have the simulation model in the form of a deck, with inputs and outputs and with an AI implementation. We will need a signal concentrator, gateway, Wi-Fi and Internet router. A mini PC could be supporting and hosting the BMS and the simulation deck. We need to create the simulation model and that mean an engineering service to be provided, with previous information taken in the field. And finally we will need extra sensors and validation tests to make sure our model is representing well the reality. In our case and taking into account the IDA committee resolution of the past 5 April, we could describe our system as follows. There is no special risk associated of those described in the document. Liability may be directly connected with the product and services supplied by a company. The model used is compiled but it may be studied component by component, using libraries which programming is known and supported. The values we see in the deck are decisions to simplify the user interface. But any value can be made public. Human supervision is needed to help in the validation and analysis of the service. In this supervision processes special care with privacy must be taken. More precisely, this privacy tool is directly helping to get some of the objectives of the EU Parliament Commission. It will serve as base for a standard. It is a way to mitigate risk. It can create certainty for developers and EU companies. It may create an open certification platform providing trust. It can be a risk-based legal framework. It can provide a way to make a risk assessment during design processes. Research must continue to get standards permitting good levels of privacy by design. We propose a new way of data processing in the edge. We have tested these methods in demo pilots of Sphere project.
The Privacy Metrics tool draft is provided in Excel format with a help in Word. It includes some basic examples to understand how it works. You will find in columns the so-called categories. Inside each category there are items and scores. Calculation is made using these scores as it is described later. What is privacy content? It is impossible to measure privacy, but we can implement a way to evaluate the level of privacy comparing situations. We divide the big problem into segments or categories. Applying an algorithm we can get a number representing the privacy content. Categories would be the aspects involved in the calculation. We are working in this first draft with 6 aspects: entities, magnitudes, statistics, sampling frequency, data use and data control. An item would be an occurrence inside that category. We can only have one item in each calculation. Items are exclusive. We can find many items and the list can increase to consider all possible options. In some categories as data use, or data control, the number of possibilities can increase a lot. It will depend on new uses and control options which are continuously being developed. Score associated with each individual item would be a number which will be considered in the global privacy metric formula. Numbers must be understood in order of magnitude and in a differential way. As soon as you define the value 1 for one of the items, all the rest are established in relation with this item. One of the categories, magnitudes, represent the privacy content included in different physical measurements.
To get the final estimation of privacy content, we would be multiplying the scores of categories, entities, magnitudes, statistics, and sampling frequency, and dividing by scores of categories, data use, and data control. An example could be this one. Detecting human presence in real time from home to owner. In this case we would have entity equals human, score 1. Magnitude equals pre-presence, score 1. Statistics equals sampled data, score 1. Sampling freak equals less than min, score 1. Data use equals storage in-house, score 1. Data control equals individual control, score 1. The final value is 1. If we consider 5 as a risk limit, we would with this result, privacy compliant, acceptable or any other classification. This would be the view in the Excel file. It is important to mention relationship between privacy metrics and data ownership. Category data control is indicating who is controlling data. The owner controls his/her data and at one point may want to sell, report the set of data. The owner must have tools to provide a right privacy content in that set sold to third parties, and tools to manage the sale process. This may be a selling process P2B or a reporting P2G, B2G process, but in any case privacy content must be known and controlled. Certified processes by independent third parties, BDTA, may be critical to initiate this data market.